Okay, we're going to look at the last section of geometry reasons, tangent reasons, all about tangents and circles. Here, we mentioned this first one before, that if you've got a tangent line, a line that touches a circle in one point, and it's connected to the center, so you've got a radius there, that tangent is perpendicular to the radius. That angle there is 90 degrees. That's real important. It's an important idea used a lot. We don't have to prove it, but you have to know it. Here's another one you don't have to prove, but you have to know. If you have, say, two tangents and they connect together at a point, the distance between the points where they touch and this other point, they're going to equal each other. AB will equal AC. Two tangents drawn to a circle from the same point outside the circle are equal in length. Okay, so that's important. And all you write is tangents from the same point, just that abbreviation. That's all you have to do. Now, here's a really important idea. It's called the Chord Theorem. I'm going to read it out, and then I'm going to explain it. Maybe won't understand the words the first time, but I'm going to explain it. The angle between a tangent to a circle and a chord drawn from the point of contact is equal to the angle in the alternate segment. Okay, let's take a look at what this means. There's the tangent, and here's the chord, BD. The angle between the tangent and the chord is D1 right here. It's that angle right there. Now, with the chord theorem, there's always a triangle that goes to the outside of the circle, that's on the circumference of the circle. And the angle between the tangent and one side of the triangle, one chord, is equal to the alternate angle, this angle A at the top of the triangle, the angle that actually subtends that same chord, that opens up to the same chord. On the other side, you've got D2, and the alternate angle is B, the angle that opens up to that chord AD. So D2 is the angle between the tangent and the chord AD, and the angle B up at the top is equal to D2. Well, go over this and make sure you know it really well. D1 equals the angle A at the top of the triangle here. And D2, this angle right here between the tangent and the chord, it equals the angle at the top there. Go over it as many times as you need to make sure you understand the chord theorem. There are two proofs here. You learn them, you just have to memorize them. I'm not going to go through them. You have to go through them really closely, step by step. And look here, you can see they're trying to prove that BCBD, so go to CBD, there's angle 2, that it equals the angle BED. That's the angle up at the top. Well, that'd be the chord theorem if we could prove that. Well, they tell you exactly what to do. The first thing is a construction. You have to draw this dotted line. It's not there. You'll just have this picture. That's BOF. And then you have to draw the little dotted line here, EF. And you use those two things and a bunch of steps to prove the chord theorem. And there's one for an acute angle and one for an obtuse angle. You just have to go through it, and you just have to learn it. I'm going to do one example now, though, of a question that uses all this stuff. Okay, let's start off here. Say you had to figure out what angle A and angle B and angle C is. You've got a cyclic quadrilateral here. It looks like D, B, F, E. There's two triangles in here. You can see two triangles and two tangents, ABC and CF, two tangents. Well, let's look at the first one here. That tangent is perpendicular to the radius. That's 90 degrees. Well, that makes A 55 to make this add up to 90. Tangent perpendicular to radius. Now, this angle B here opens up to the diameter, to a semicircle, to a half circle. So B is equal to 90 degrees, angle in a semicircle. These angles here, C1 and 66, are angles in a triangle. You can angle sum in a triangle. That's what you should write, not this interior thing. But in the memo, I use exactly the right reasons, and I've given you two sheets You have exactly the right wording, the exact right reasons to put down. We know that BC equals CF because of tangents from the same point. That means F1 is equal to angle C because equal angles opposite equal sides. And then they just have to add all up. If that's C and C, that's 2C plus 66 is 180. That's angle sum in a triangle. Subtract 66, 114 divided by 2, you get the final answer. I gave a bunch of questions here. I gave 6 plus, 5 plus 6, 11 questions to practice the tangent reasons. And they come with memos, complete with the exact right answers that you're supposed to write down. So it just takes a lot of practice. So you got to go through all this stuff. Good luck with it. And I'll stop there.